Okay, we have already worked with angles, and we're going to continue working with angles today. So the box up at the top here should be a little bit of review. We've talked about how to name angles. So if I want to give this angle a name, it's angle ABC. I could also call it CBA. And since it's the only angle in this diagram, I can also call it angle B. Now, I wouldn't want to do that with this picture if we kind of look ahead, because if I said angle B here, you'll be like, which one are you talking about? Are we talking about this one? Are we talking about this one? Or the whole angle? So only if it's the only angle in the diagram can you call it by its vertex. Okay? The angle has two sides, and they're rays. So ray BA is one of the sides, and ray BC is the other side. B is the vertex, and I can also say the measure of angle ABC is 40 degrees. Now, when we worked with segments, we did the segment addition postulate, and now we have the angle addition postulate, which I think will, now that we've done segment addition, will make pretty good sense to you. If we look at this diagram, right, if I were to label it with some values, I could say, for instance, that, you know, this angle here is, I'm just making this up, 35 degrees, and this one is 80 degrees, and then I would know that the whole angle, angle ABC, is 80 plus 35, 115, right? I can add those up. So that's the angle addition postulate. The measure of angle, and I got to be very careful how I name these, ABD, plus the measure of angle DBC equals the measure of angle ABC. So in this drawing, the measure of angle ABC is 80 plus 35, 115. Why this keeps going blurry. Okay, now we can apply that postulate to lots of different types of problems. Here's another diagram of a couple of angles together, and this is when, you know, labeling is going to be important, that we label things correctly so they make sense. This says a measure of angle DEF, so that's the big angle, is 7x plus 4. Measure of DEG is 5x plus 1. So DEG, I'm going to squeeze a little 5x plus 1 here. And GEF is 23 degrees. So I know that these two angles together will add up to 7x plus 4, will add up to the whole angle. So that's how I'm going to set up my equation. 5x plus 1 plus 23 equals 7x plus 4. Now I just have to do algebra to finish this. Combine like terms on the same side of the equal sign. Bring all the variables to one side. So I'm going to move the variables to the left, to the right, so they say positive. That's just a matter of taste. You could also move them to the right, wouldn't matter. 20 equals 2x, so divide by 2, running out of space. X equals 10. Now usually, if this is an Algebra 1 problem, we're celebrating here because we're done, but we're not quite done here. We're finding the measure of DEF. Okay, so DEF is the full angle, which is 7x plus 4. So I'm going to plug in that 10 here for x, and that's how I'll find the measure of angle DEF is 74 degrees. And don't forget to kind of box that final answer and show all those steps. Now when we did segments, we had segment bisectors, and bisect just means to cut something in half into two equal pieces. Same idea here. An angle bisector cuts an angle in half and makes two congruent angles. So if I look at this picture, what I see there is that ray AC bisects angle BAD. And the way that I would mark that in the diagram is to show that these two angles are congruent, I would put the same number of little arcs on them like that. You could either do 1, or you could put 2 or 3. As long as you're consistent, that shows that the two angles are equal, and that's the angle bisector. Now I can apply this principle to different problems, and we got a lot going on in the next one, so labeling is going to be very important. This says that ray BD bisects CBE, so it cuts CBE in half. So this angle and this angle will be congruent. So I'm going to mark them to show that. BC, ray BC is perpendicular to ray BA, so I'll mark that as well over here. I'll put a right angle. The measure of CBD is 3x plus 25. So measure of angle CBD, 3x plus 25. And the measure of DBE is 7x minus 19. And since I know that that's a bisector and those two are congruent, I can write an equation, 3x plus 25 equals 7x minus 19. And now I just have to solve it. Bring all the variables to one side again. So let's see, 4x is 44. Okay, that's easy. I was worried. 11 equals x. Okay, and again, we're not done yet because it says to find the measure of angle ABD. And when I look over here, I see ABD, that's this obtuse angle here. It's made up of two different angles, the 90-degree angle and the 3x plus 25. So if I want to find the measure of ABD, I need to add 90 plus 3x plus 25. And I'll plug in my 11 for x. Measure of angle ABD, 90, 33, and 25. And 90 plus 33 plus 25 is 158. How did I do that so quickly? Because I just did this whole paper but forgot to turn the camera on. So, and it's not 158, it's 148. Let's erase. 148. Okay, I like to put that in a nice box to show, okay, that's my final answer because I'm addressing that question. Okay, so that's using angle addition postulate and angle bisectors. We're going to go to the back because there's some more sort of vocabulary that we're going to see all the time in this class. So let's go to the back. These are called angle relationships, and there's a few important words that we need to recognize. Two angles that are across from each other on intersecting lines. They are always congruent. So let's just draw a picture here, and we don't need to add too much detail to it. I'm just going to show you. In this drawing, these two angles that are across from each other are always going to be congruent. So I can mark them like that. Those are called vertical angles. And you will see that show up all the time. I like that rule, or I like vertical angles because they look congruent. Like it just kind of makes sense that those two are always going to be congruent. Now, I don't want to put the markings on the diagram because I don't want it to be kind of too crazy, but this angle over here is also congruent. These two obtuse angles are also congruent that are across from each other. Okay, adjacent angles, we'll work our way around this way. Adjacent angles are two angles that are next to each other and share a common side. Now, we've already seen diagrams so far today with adjacent angles, so I'll just draw here. And we'll call that B, A, C, and D. So I'm talking about angle ABC and angle CBD are adjacent, meaning that they are next to each other and they share a common side. Okay? All right. couple other words we'll see a lot. Complementary angles. Those are two angles whose sum is 90. And just for contrast, I'm going to draw these as non-adjacent angles. So, for instance, we'll call this one angle A. Remember, if there's only one angle, then I can just call it by that. And here's angle B. We'll make that one 50, right? These are non-adjacent complementary angles. Angle A and angle B are complementary. And they're also non-adjacent, just so you see the difference. They're not sharing a common side. All right, we have complementary angles that will add up to 90 degrees, and then we also have supplementary angles. Supplementary just means that their measures add up to 180 degrees. So for instance, we'll draw angle P, and we'll make that one 120. And over here, I'll draw angle Q, and I'll make that one 60. So these, angle P and angle Q, are supplementary, and they're also non-adjacent in this picture. Right? Supplementary just means that they add up to 180. Okay. Now, a linear pair is like a combination of these things. A linear pair are two supplementary angles that are also adjacent. So I'm going to start my linear pair drawing by drawing a line. And then like this. So these two angles, and we can label them. Angle ABC, ABD, and angle DBC are a linear pair. And that just means that they add up to 180, they're supplementary, right? And they're adjacent. So the angles have to be adjacent to be called a linear pair, meaning they're on the same line. And you might see angle ABC called a straight angle, and that just means it's 180 degrees. Maybe we should write that down too. That's just like a angle ABC is a straight angle. 180 degrees. Okay. So we could put some numbers in these just to give the context. We could say, okay, this is 130 and that's 50. Right? They add up to 180. That's a linear pair. Okay. Now, you'll see these vocabulary words regularly, and we'll need to kind of apply them to our work, or these concepts. So let's take a look at a couple problems down here. Angle DEF is a straight angle. That means it's 180 degrees, right? DEG is 23x minus 3. 23x minus 3. And GEF is 12x plus 8. Find GEF. Okay, I have a straight angle, right? That's 180 degrees. These are the two angles that make up that angle. So I know that if I add these two together, I'm going to get 180. So again, this is the tough part about geometry, is we got to write our own equations and then solve them. Okay, so 23 plus 12 is 35x. Combine like terms, plus 5 equals 180. Subtract 5 from both sides. I don't like this. I messed something up. Plus 8. 35x equals 175. Pause for a second.